Today's lesson, Aromaticity. In this lesson, we are going to learn what is aromaticity, which compounds are aromatic compounds and which are not, and why. In this lesson, some compounds will be discussed as examples. So let's get started. First of all, which compounds are aromatic compounds? At the very early stage of chemistry, aromatic compounds are defined as the compounds having aroma. Aroma means good smell or good scent. That is aroma. Meaning is good smell or good scent. At the very early stage of chemistry, aromatic compounds were with good smell. Later, the definition is revised as benzene and derivatives of benzene. This is one derivative of benzene. This is derivative of benzene. This is derivative of benzene. These are derivatives of benzene. That is, now the definition is benzene and derivatives of benzene are aromatic compounds. Finally, the definition is revised according to German chemist, physical chemist Erich Hückel in the year 1931. Let's see which are aromatic compounds according to scientist Erich Hückel. Erich Hückel in the year 1931 put forward some rules for aromatic compounds. One is aromatic compounds must be cyclic and flat or planar. Each member of the cycle will have unhybridized p orbital. This p orbital will be perpendicular to the cycle plane. That is, p orbital will be perpendicular. Then this p orbital will form molecular orbital over and below the plane. This molecular p orbital contain 4n plus 2 pi electrons. These pi electrons must be delocalized. Here, value of n will be 0 or 1 or 2 or 3 or 4, etc. That is, values of n will be integer, not fractional. That means aromatic compounds will contain delocalized electrons 2 or 6 or 10 or 14 or 18 and so on. Because of these delocalized pi electrons, aromatic compounds will get more stability, and aromatic compounds, because of this more stability, aromatic compounds will undergo special substitution reaction. So finally, according to German chemist Erich Hückel, Aromatic compounds will have these properties. That is, the compounds that will have these properties, these compounds are called aromatic compounds. And the properties of aromatic compounds are known as aromaticity. That is, aromaticity is a property of aromatic compounds. That is, aromatic compounds that show the special properties, that properties together called aromaticity. Now let's see, according to Hückel's rule, which compounds are aromatic, which are not. First of all, let's write a compound. This is a compound. Its name is cyclopropenyl cation. Let's see whether this is aromatic. Because of this positive charge, these pi bonding 2 electrons are delocalized. This is flat molecule. Each member of the ring has unhybridized p orbital. Now let's see about delocalized pi electrons. Here 4n plus 2 pi electrons. 4n plus 2, here number of pi electrons 2. We know one pi bond is constituted by 2 electrons, so that is why this is 2. Here n is equal to 2 minus 2, this 2 divided by 4, 0 by 4, that is 0. Value of n here 0. So this is aromatic compound. Cyclopropenyl cation is a kind of aromatic compound. Let's see another example. Now the compound is benzene, which is cyclic and flat or planar. Let's see about delocalized pi electrons. 4n plus 2, here 2, 4, 6 pi electrons. Here value of n is equal to 6 minus 2 divided by 4, that is 4 by 4 is equal to 1. So benzene undergoes 4n plus 2 pi delocalized electrons. So benzene is a kind of aromatic compound. Let's see another example. Now the compound is pyridine. Here nitrogen is sp2 hybridized, so it has one p orbital that is unhybridized. This p orbital forms pi bond with this carbon with unhybridized p orbital of this carbon. So here 4n plus 2 pi electrons, 2, 4, 6, that is n is equal to 6 minus 2 divided by 4, 4 by 4 is equal to 1, that is pyridine is a kind of aromatic compound. Now the compound is Pyrrole. This is Pyrrole. Nitrogen contains lone pair of electrons. Here this nitrogen is sp2 hybridized, so it has one orbital, p orbital, that is unhybridized. This p orbital contains this lone pair of electrons that participates in the formation of pi molecular orbital. So here 4n plus 2 pi electrons, 2 4. These two electrons participate in the formation of pi molecular orbital. That is, these lone pair of electrons remain in the unhybridized p orbital. That is why these pair of electrons are involved in delocalized pi electrons. So value of n will be here 4n is equal to 6 minus 2, n is equal to 4 by 4, 1. So this compound, that is Pyrrole, is a kind of aromatic compound. Now the compound is furan. Oxygen contains two lone pairs of electrons. This oxygen is sp2 hybridized, so it has one orbital, that is unhybridized p orbital. This oxygen is sp2 hybridized. Orbital structure is like this: sp2 orbitals. One hybrid orbital contains one lone pair of electrons, and unhybridized p orbital contains another pair of electrons. These lone pair of electrons that reside in the unhybridized p orbital that participates in pi molecular orbital. That is, these lone pair of electrons that remains in the hybrid orbital, sp2 hybrid orbital, and another lone pair of electrons that reside in the unhybridized p orbital that participates in pi molecular orbital. So here number of pi electrons will be 2 4 6. That is one pair of electrons that reside in unhybridized p orbital that participates in pi molecular orbital. But another pair of electrons that reside in the hybrid sp2 orbital that remains as lone pair of electrons. Now value of n is equal to 6 minus 2 divided by 4, that is 4 by 4 is equal to 1. So this compound, that is furan, is a kind of aromatic compound. Now the compound is thiophene. Sulfur contains two pair of electrons. One pair of electrons reside in sp2 hybrid orbital, and another pair of electrons reside in unhybridized p orbital. These pair of electrons participate in the formation of pi molecular orbital. So here 4n plus 2 pi electrons. 4n plus 2 is equal to 2 4 6. So n is equal to 1. That is, thiophene is a kind of aromatic compound. Now the compound is naphthalene. Here 4n plus 2 pi electrons, 2 4 6 8 10. This is 10. N is equal to 10 minus 2 divided by 4, 8 by 4, 2. Naphthalene is a kind of aromatic compound. Value of N is equal to 2. The compound is anthracene. Here 4n plus 2 pi electrons, 2, 4, 6, 8, 10, 12, 14. Here value of n is equal to 14 minus 4 divided by 4. That is here 14 minus 2. That is 12 by 4. Here 3. Value of n is 3 integer. So anthracene is a kind of aromatic compound. The compound is this, that is cyclobutadiene. Here 4 carbon atoms that contain unhybridized p orbital that forms pi bond. This is cyclic, flat or planar. Each member contains unhybridized p orbital, but number of delocalized electrons, pi electrons, 4n plus 2, pi electrons 2, 4. N is equal to 4 minus 2 divided by 4. 2 by 4, that is half. Here value of n is fractional, not integer. So cyclobutadiene is not aromatic compound. This is anti-aromatic compound. This is all about aromaticity. No more today. Thank you very much.